Hi, I'm going to explain to you what we perhaps you didn't quite get about counting principles and the different techniques we were using to count faster. Of course, I can always count just by making a long list of the different ways in which things can be arranged, but there are some tricks that you need to master. So here's a bit of a summary of the activities we were doing in class and ways to think about it. And ultimately, also, I'll finish with the actual tools that you need. So the first question we asked is that I had four letters A, B, C, D, and I asked you to see how many different ways can I arrange them. Now, one way to do it is to just start writing. You say, okay, so first one is going to be A, B, C, D. Then I'm going to have A, C, B, D. And I'm going to have A, C, D, B. And there's also, well, of course, I could say A, B, D, C, and so on. And it's going to take a while. But one thing I want you to observe in the way I was producing this list is that there's a bunch of arrangements that I can do if I start with the letter A. But once I start with the letter A, I'm going to have to choose whether I'm going to have the letter B following, or the letter C following, or the letter D following. There's three options. And look at this point here. I have A and B, right? I look at my first two letters. What are the options for which letter comes third? Well, there's only two options left. And once I have that one, that's it. Well, if I have A, B, and D, obviously the last letter is going to be a C. There's just one option left. So if I start to think, okay, how many can go in the first position? This is going to be the first position. Like I have the A here. Well, I can start with the letter A, or with the letter B, or with the letter C, or with the letter D. I have four options. And once I choose one of those letters, right, whether I start with A, B, C, or D, independent of which one it is, let's put a C here, for example, I'm going to have only three letters left. And it's going to have to be one of these three letters that I'm going to have to choose to put in the second position. So for each of the four letters I can put in the first place, for each one of those, there are going to be three letters I can put in the second place. And for each, once I have the first and second letter, I'm going to have two spots left. And for the third spot, I'm only going to have two. And finally, 1. So the fast way to calculate this is 4 times 3 times 2 times 1. And the reason I'm multiplying is because I said for each one of them. So if I have, if I start with the letter C, right, I'm going to have 6 possible ways to arrange the remaining letters. If I have the letter A starting, I'm going to have 6 different ways. So for each one of the 4 letters, I have 6 different ways. Therefore, I end up doing 4 times 6, 24, which is the answer. So that's one of the exercises we talked about. And that led us to the formula that we call the formula for permutations, which is n factorial. And remember, n factorial means n times n minus 1 times and all the way until I end up with 3 times 2 times 1. So for example, 4 factorial is 4 times 3 times 2 times 1. I asked you guys, okay, so if I have 5 numbers, 1, 2, 3, 4, 5, how many different 2-digit numbers can I do? It's kind of similar, really. For the first position, I have 5 different options. I could start with the number 1, or the number 2, or number 3, number 4, and number 5. And for the second position, I'm going to have 4 different options. And there's no more, so it's not really factorial anymore. Think about it. I could start with 1, and then put a 2, or 1, and then put a 3, or 1, and then put a 4, 1, then put a 5. So there are 4 options for the 1, and then I'm going to start with a 2. So 2, 1, 2, 3, 2, 4, 2, 5, 3, 1, 3, 2, 3, 4, 3, 5, 4, 1, 4, 2, 4, 3, and 4, 5, and finally 5, 1, 5, 2, 5, 3, and 5, 4. So you can see the first number could be 5 different numbers. But once I place the first number in the first position, I only have 4 numbers left to place. So the answer is going to be 5 multiplied times 4. So the answer is going to be 20. Now there's a formula for this, which basically says, look, I have a number n of different elements to choose from. In this case, it's going to be 5. But because I'm only choosing 2, I'm going to just do 5 times 4. I'm only going to do it 2 times. So what I'm going to do is I'm going to divide by n minus r factorial. Now this seems like a complicated way to do it, but if you think of what's happening here, I'm going to have, well, 5 factorial divided by 5 minus 2 factorial, because I'm only choosing 2. And that's going to result in 5 times 4 times 3 times 2 times 1 divided by 5 minus 2 is 3, so 3 times 2 times 1. And now these ones will go away, and I will end up with the same number that I figured out. This formula here is just a way to do things a little faster. And it seems a bit more complicated than it really is, okay? Now keep in mind that all you're really doing is kind of shorting down your factorial. So you're not multiplying all the way down to 3 times 2 times 1. You're just going to stop when you need to stop. You only have 2 numbers, well, 5 minus 2, so 3, divide by that and get rid of the other numbers. There are many more things about counting principles. Let's look at the next exercise we also did in class. So what happens if I have a repeated letter? Now this is a way in which it starts to become quite tricky. Well, there's so many ways to do this, but here's one idea. Of course, again, same principle. I could start with the letter A, B, C, C, or D. But the problem is that if I do 5 factorial, I'm going to be counting situations where I'm going to have the same thing all over again. Why? Because I'm going to be having A, for example, B, C, D, C, and if I'm doing 5 factorial, I'm counting like the 2 C's were different, so I'm going to have another arrangement where it's going to look exactly the same. Then the only thing is that these two have changed positions, but that's irrelevant. I can't really see any difference between the 2 C's. So somehow I have to narrow down for that. There are so many ways in which we can think about this, and I'm just going to choose one because I think it's useful. And for this example, why not? If you think about it, each one of those arrangements that you have, since you're doing all of the possible arrangements, you're going to have 2 of them where the C's have changed position. So for each one of these arrangements, there's going to be one where the C's have changed position. So in a way you can think of, well, they're doubled. There's twice as many arrangements as there really are. So I can actually account for that. Well, how about I count all the different possible arrangements there are with the 5 letters and then divide by 2 because I know that they are doubled. I can very quickly do that. It's going to be 5 factorial divided by 2. And that's going to be 120 divided by 2. And so the answer in this case is 60. There are so many ways to see this exercise that if you don't quite get it, just come back and we can look at it together.